Hello and welcome to the Drugst.One Standalone tutorial. The Standalone implementation and this video might be relevant for you in case you do not want to integrate the whole Drugst.One component into your website, or you do not have a website to begin with. We provide a manual solution and a URL-based configuration, and we will look into all of those options in this video. Let's start with just using the Drugst.One Standalone implementation manually. It can be found here on the Drugst.One website, and there will be a preloaded network, but I will quickly grab the example genes we always had in the previous tutorial videos and replace the example network here. The standalone implementation does not provide control over many Drugst.One configuration options, especially not about the features and different panels or functions. But we can, for example, define again the dataset that is used to explore different data types. So I will also quickly change it, like in the integration example, to OMIM, and we can also generate or regenerate the findings we had there. And this is, apart from the gene node style, quite similar to the previous tutorials. Other than that, all the panels and features are just enabled by default to allow for any exploratory analysis that Drugst.One can provide. And that is also the main goal of the standalone implementation, to just serve as a basic Drugst.One implementation that allows the exploration of small sets of genes or proteins with all the Drugst.One functionalities that one would also get from integrating into their own website. Now let's take a look at other ways to use this Drugst.One version. For this, I will quickly go to the documentation, the standalone chapter, and the API part. And we will start with the GET request based configuration here. And if I just copy this example, it should be quite apparent what is going on here. This example shows how Drugst.One configuration can be URL encoded. This allows to define networks to be loaded. For example, here, just transferring the nodes and the edges, and selected parameters, like here the autofill edges, to be directly applied to this Drugst.One instance on that page. So let's use this to change our Drugst.One integration example from the previous tutorial to a redirect example. As a small reminder, the example website is just a website that randomly splits a list of defined genes into two groups, relevant genes and irrelevant genes, and load them into the network in this case. So now I start by quickly changing this Drugst.One integration to display a link. For this, I will use an anchor tag and remove all the configuration. And of course, I have to adjust the set network function. And for now, I will just use the relevant genes to construct a request that looks like this. And as we see in this example, this is how the get parameter has to look. So comma separated gene names, meaning we'll just go ahead and do exactly this. And quickly rename this to our Drugst.One link element, because we now have to set the href attribute of this anchor, so the Drugst.One link, and the href just defines the link location. That of course has to be the request. So let's look at our example website. No link is not active. Once we click and prioritize genes. We get a link. Let's use these. And as we see, successfully the 4 relevant genes in this case are redirected to the Drugst.One standalone. I will quickly add a target blank that just opens it in a new window, which makes it just more comfortable to use. Perfect. Of course, there are again some parameters that can be adjusted so that the network and Drugst.One component are a bit more customized. One you already saw in this getRequest example, this autofill edges parameter. And now let's quickly look at the parameters that will reconstruct the previously integrated network as good as possible. That would of course be the physics on parameter, then the license datasets parameter to use OMIM as associated protein disorder dataset, as well as enabling adjacent drugs and adjacent disorders by default. And let me quickly generate that string. And this is now our new URL request. If you're not familiar with getRequest, there's also a link to just a general wiki entry about HTTP GET requests. But the essence is that different parameters are just separated by this AND sign, and the value is just coming after an equal sign. And this is now how the new URL request looks like. And let's see if it works. Maybe a bit more genes. Let's go for 3. And as you can see, this URL is now terribly long, but it exactly depicts what we aimed for before. So again, physics is enabled, the adjacent diseases and proteins are already displayed, and so on. To improve the visual appearance of this link, we offer Drugst.One button or link styles. They can be found in the Standalone chapter in the documentation under buttons. And for this, we can import another style sheet first. And we just have to do it like with the other Drugst.One style sheet. And now the only thing we have to decide on is which style of these example styles do we want to apply to our website. I will just go with this first one. And so I will just copy and paste the classes that I will now apply on the anchor, so the link we have on the website currently. And let's go back to the example page and generate a nice network. Yes, works the same, but now we touched up the visual appearance. But again, as before with the manual configuration, the options that are here are just selected options and not the full list of parameters that there are. This leads us now to the post request based configuration that can be found here. Basically, the options here are unlimited to parameterize and customize the Drugst.One standalone component, apart from the component styling and colors. The nice thing is the configuration here is exactly the same config, string, and objects as the Drugst.One component uses. So the network string, the group string, and the config string. So let me start by getting some old code from the integration example here. And I will quickly get the network object generation here, because as I just showed you, it's exactly the same object that is needed here. I can get rid of this request for now. And there we already have on the network object. And in the same process, I will already grab the group config object. And also the config object. If you're interested in how these were generated and what these exactly do and how you can interactively configure them, yeah, please check out the configuration or the interactive configuration tutorial. So that is our 3 strings here. And the second prerequisite we need now is to execute post requests. For this, I will resort here to Axios. And depending on your method or framework, the import of this post request function might be different. But in my example, having just a single page HTML file with just a script block, I have to resort to import the Axios package like this. And now let me quickly write a small wrapping function for the Axios post requests. Yeah, so exactly like this. And let's see the documentation about the post request now, what the next step is. What we see here is that the post request should be executed on this URL endpoint, and the payload object should look like this. So let's quickly adjust this in the code. So let's create the payload object first. With all the different configuration objects. And now let's copy and paste the post request URL, which is this one, for example, and add the payload. By executing this call, the network, together with the configuration and the groups, will be stored on the Drugst.One server and can be referenced by a unique ID. And this unique ID, as this text here tells you, will be in the response of this post call. And this network ID can then be used to reload this network within the standalone Drugst.One component. And so let us quickly handle this response. And we'll do this like this. And the network ID will be the data of the response. And let's quickly update this Drugst.One link here then to whatever the documentation says here. So it's again a GET request in this case, but the ID is the only parameter. So do it like this, plus network ID. So now let's test the post-based configuration and redirect now. So generate some network, perfect. And indeed, I'm redirected to the Drugst.One page, and you can already see the unique network ID that is encoded in the URL up here. I agree, which means we loaded the OMIM dataset as defined in the configuration. And also what you can immediately see that the configuration is applied because we disabled some panels here and some functions and enabled some default features here, like the adjacent drugs and adjacent diseases. Also, the genes are split into irrelevant and relevant genes, as it was previously defined and configured in the configuration tutorial video. And that was just by reusing the configuration objects from this example. And as we did it in this configuration example, of course, all the strings that are generated here in this playground can be used to redirect to a Drugst.One standalone instance. So in any case, this playground and also the documentation with an overview over all configuration parameters are great resources to help you also to create your configuration if you only want to redirect to Drugst.One. As a last quick example, I want to show you that not only websites can redirect to Drugst.One, but basically any application, including Cytoscape apps or command line tools, can redirect to Drugst.One and present results this way in a nicer fashion. I already prepared a small Python script that I will quickly explain. So here we have just imports. In the first 4 lines, I only try to mimic the behavior of the example website. So splitting a list of input genes into a list of relevant and irrelevant genes just by random. In this line, I then construct the network object used for Drugst.One and already set the relevant and irrelevant group tags. In this next line, I just construct the payload object already with groups and config objects in there, and I just change the title to see that we are coming from Python. But that's of course just the title and has nothing to do with how it works. And finally, I will use the requests package of Python to send a post request to the same endpoint as before, and hand over the payload object here using this JSON attribute and receiving a response. The response then contains the network ID, and I can construct the URL again as we did before. And this last line will just execute a system command that will open Google Chrome on my PC and show the URL. Let's quickly okay. And now we can execute the script. To quickly go back, it's the same genes as input list as we used before, and again it looks nearly indistinguishable. We have another network ID of course now, but the settings are completely the same. But here is our from Python title, and this time we did not send this request or redirect from a website, but just from a generic script. All this allows most tools to use Drugst.One to improve their result visualization and offer network-based exploratory analysis functions and drug repurposing utilities to their users. So feel free to use Drugst.One or to just try it in your application. Check the documentation and reach out in case you experience some issues with your tools in combination with Drugst.One. Contact information can be found here. And thanks for watching.